custom domain name, whatever you name you want to give, myapp.local, and then save this and come to your browser, myapp.local. You should be able to access your application right here, and this is how you deployed. And now you, as many as pushes made to your this repository, that is create a CI/CD on main branch. This workflow will be triggered, and a new image will be running on your workflow. As now I we have here. Now let me show you how rollback will be happening with the zero downtime, as I explained. Hey, hello everyone. Welcome back to the Kubernetes project series. This is the fourth project of our Kubernetes project series. And in this video, we are building an end-to-end CI/CD pipeline for deploying our Kubernetes application using Helm charts. And if you don't know what is Helm, I'll give a brief overview of what is Helm and why to use Helm shortly. And we will also explore the rollback strategies to roll back to our previous application versions intentionally or if anything goes down with zero downtime, ensuring we'll achieve an high availability and seamless deployment. The key word is I took here is zero downtime. We will ensure that we will have a zero downtime if we roll back to our previous versions. And if you guys are new to this series, I have already created three projects of this series. I highly recommend you to watch those three videos, not three videos. If not three videos, I highly recommend you to watch this third project, because this project is the baseline for that third project. Because in that project I explained how to deploy Kubernetes application manually, like using this command kubectl apply, all the commands, all the resources using that kubectl apply command. I have also explained there how to use an external volume, that is AWS EBS. And also I've explained there how to create a custom domain. So I highly recommend you to watch that previous video. And this is the GitHub repository where I put all the source code documentation in this repository. All the links I'll provide in the description, so do check that out. And yeah, without getting late, let's get started. Now let me explain what is Helm and why to use Helm. So, and by the way, this is the application that we had deployed in our previous video. We are here in this video, we are also deploying the same application, but we will automate this completely using this Helm. So the problem that we are facing, or we were facing in our previous video, and that Helm will be solving that problem. What is that problem is, the first problem is, in our previous videos we were applying all the resources by using this command like kubectl apply for all the resources. Like in the production real world applications, we will be having an 50 or 80 number of services or resources to apply them. So it will be very hectic work to apply all those commands one after the other. So what Helm does is, Helm packages all your commands in just one single wrapper and gives us a single command. By that single command, we can apply all the resources in just single command. So that is what Helm uses. Helm uses power. So Helm is like a package manager. Like we have apt for Linux, npm for Node.js, pip for Python. Similarly, Helm is like a package manager for Kubernetes. That, like, it just packages all your commands and gives us a single command to apply, by which we apply, and our application will install and run to our servers. So the second problem we faces is uh, follows the priority order. Means in our previous video, we were applying all the commands one after other. Means we were first applying our secrets configs, and then we were applying our YAML files of our database, and then we were applying our front end and back end. We were following an order, and we need to follow that order because we don't want our application to get created before applying our database or secrets, because secrets and database is needed for our application. So we were following that order, and Helm also follows this order by default. So this is the reason why we need to use Helm also. This is the second problem that Helm solves. And means what, now you may be thinking what was that order. So in this repository I have this. So firstly it will create a namespace if we have, then it will create a look for network policies, and then resource quota limit range, service account secrets configs, and then persistent volume, claim, storage clusters, and then it will look for deployments, then services, ingress, and then CRDs. This is the like priority order that it follows. So now the third problem is manage different environment with different values. What do I mean by this is, let's say you have three different namespaces: dev, production, and QV. And in three on and in three all three namespaces you have your application running. Technically what you will do is, without Helm, we'll simply go to that namespace and apply all those commands one after the other. kubectl apply, kubectl apply in all three namespaces. And if you want different resources to run, like in production if you want five resources to run, and in development stage, development namespace, you want two name pods to run, you will go to that YAML file and again make changes and apply that. So like you have multiple, yes, files with same YAML files for different namespaces, right? So that is the problem we have here. So what Helm makes easier is, Helm says is like, just simply create a template. What template means is, so let's say this creates a template. So if this is your YAML file, let's say for a front end deployment, you just create a template for that YAML file. Template means uh, for all the values that we have in that file will be applied dynamically using another file. Let's say we another file is like, this is the another file. So this is our template and this is our values file, and these values file will be applied to this template dynamically, and all the resources will be applied to our Kubernetes. The same way, let's say this YAML file, file is for development stage, development namespace. Similarly, we will be having another file for production namespace. So we have the same template, just we have the different values file. And if you want to make any changes, just we will go to that YAML file, values file, and make changes, and those all values will be applied here. So we have just single template, and we are just changing the values file, changing parameters in values file. So that will be applied directly to our servers. This is what Helm solves problem is. And the fourth problem is the rollback capabilities. Like technically, without Helm, if you want to roll back to our previous versions, we don't have which version we were in our previous, right? But in Helm, Helm stores the all the revisions that we were in our previous stages. Like currently, we are in our version V2, and we moved to our next. We made a new deployment cycle, and we deployed a new version. Let's say V3. We are currently on V3, and if anything crashes or anything happens to that new version V3, we want to roll back to our previous versions. Let's say V2 or V1. We can seamlessly ensuring that high availability. We can ensuring high availability and zero downtime, we can roll back to our previous versions. This is the power that Helm gives us. We will look into this with a demo also, how to roll back to our previous version with zero downtime. I will show you the live demo for that. So now let's start the demo part. So what I have done is, I have gone to my AWS console and I have created this instance of size t2 small, and simply connected to this instance. And in this instance, firstly we will install and set up our EKS cluster. So let's start first from updating our server. Okay, now update has been done. Now to set up our cluster, I have already provided the guide for you in our project 3 in the setup MD. So same steps to follow. So we'll simply set up our cluster over there. So firstly we will install the CLI over there. Now let's connect our AWS account to our instance, AWS configure for that. Now next is to install this Helm. Simply hit enter. So Helm will also be installed. So let's installing cluster. So version 3.4. So the name of our cluster is my cluster. So it will take nearly 10 to 15 minutes to install the cluster. So now our cluster is running. So next step is to associate IAM YDC provider. Now again, if you guys don't know this, what is IAM YDC, I already explained this all in my previous video. So I recommend you to watch that previous video. So here we will change something. So we will running just single node. Now let's create a repository here and then link that repository to our server. Which server? This server. So let's first create that. Let's name any. We'll give this repository name as KTCICD. We'll make it public and keep everything default and simply create repository. So our repository is created. Now in our server, let's make first a directory. So over here, git clone, we will clone this repository. Here our entire code is present, like our YAML files and all. So what we will do is we will take this URL, git clone, paste it over here. Now here we have all our files and folders of our application. So now git remote hyphen v. Now once we will check this git remote hyphen v, the origin of this repository is now pointing to this repository, but we don't want it to point here, but we want it to point it here. So for that, what we will do is we'll remove that remote first remote repository first. So for that, so the command for that is this git remote So now once we will check this, our remote is now removed. So now let's connect this repository to our URL. So for that, just take this command. So it is pointing to our KTS CI/CD now. So yeah, everything is good now. We have our main branch over here. Git branch. Yeah. Now let's create the Helm chart for our application. So for that, command is, Helm create and give the release name of your application. Give any name you want. For now, we are giving a rating app. So simply hit enter, creating rating app. So simply ls, and you will see here a directory called rating app. Let's move to that and see. So see. So by default, Helm creates a set of files and folders for you. Chart.ml, charts, templates, and values. This is by default created. So now let me explain all these files and folders one by one. So let me start from templates. So cd templates. So inside that you will be able to see a set of files, rather manifest files that will be deployed in our Kubernetes application. Sorry, Kubernetes cluster. And these all deployment manifest files are parameterized. What do I mean by parameterized? Let me show you one of the files. See here, you'll be seeing something like this syntax, and these all values will be coming from this values.ml. These all values will be fetched from this values.ml. So I think you will not be able to understand here. So let me come to my VS code, which is a local setup. So here, this is the same setup that I have in my server. So this is that Helm chart. In this Helm chart, I have charts, templates, chart.ml, and values file. And in this templates, I have created all the manifest files that are required for me, for our application. Here by default, cd template. Here by default, Helm will create this set of files for you, but we don't want these all files because we want our manifest files for our application. So we will delete these all files and we will create our own manifest files. So that is what I have created in this templates folder. So you can see all those manifest files, and these are all the manifest files that I have created by referring our previous manifest files in our previous project. We had these all manifest files, right? Backend deployment. I have referred these files and I have created these manifest files. How I have created? So let me show you one of the file. So this is backend.config. Whichever the values that are changed frequently, for those all values I am passing values dynamically through this values file. Let me show you. See a dot values dot backend dot frontend URL. Inside dot values file, in this file, in a backend frontend URL, this value will be fetched to here. Same thing happens for all. Here port dot values backend dot port. So in values file backend port 5000 will be taken, and same here dot release name. What is this dot release? I will explain you while installing our Helm chart. What do I mean by installing? It simply means deploying the Helm chart. Next is we are done with templates. The same way I have done for all the manifest files. I will share the complete code for you in my GitHub and in description. You can check that out. And next we have values file. All the values will be present in this values file. And next chart.ml. This simply contains the metadata, release name, application version, and all. And here in charts, this chart folder contains subcharts of our application, but in this project we don't have any subcharts for now. So simply this is empty. So yeah, this is our simply explanation of our all these files. So now all these files are created. So cd template. So what we'll do is we'll delete all these files and we will take these all files that I have in my local to here. So simply hit enter. So it will ask for permission. So it will copy all your YAML files to your server. So it is copying C. So now come to our server, place cd templates. See, you will be able to see all those YAML files. So let me cat and see one of the file. See, we have all our Kubernetes template files are here. So now we have our rating app. Inside that we have copied all the templates of our Helm chart. So now let's look into the CI/CD part. So we are using GitHub Actions. So for that, let me take you to my local setup. So in that, firstly we are creating this .github/workflows directory, and inside that we are creating two files. One is deploy.yaml and another is rollback.yaml. This deploy.yaml will be triggered on every push made to the main branch, and this rollback ML is like a manual setup. Means if you want to roll back to previous version, you can use this rollback. So now let me explain you this deploy.ml. So the name of our ML file, and on push branch, on every push made to this branch, that is main. So every push made to the main branch, this workflow will be triggered. So env, so we have two variables so that we can use these variables in any job. So what now, next we have the jobs. So in this workflow we have two jobs, that is build and push, and there is deploy. So first is build and push. So here GitHub Actions runner will set up a server for us of Ubuntu latest operating system in that. And in that, code checkout will happen, means all the code of our repository will be taken to that server. Inside that server, firstly we are generating that new tag. And how then we are generating new tag is, by default the tag name we have given as CICD v0, and every time a push made to our repository, the tag will be updated like CICD v1, v2, v3. It will incrementally increase. That is the logic behind this all lines, and the tag will be stored in this variable new tag. And next we are logging into our Docker Hub. We will look into this Docker Hub tokens. I will show you how to add this tokens inside your repository. That is Docker Hub token and Docker Hub username. We need to add these two secrets. And next we are building and pushing that image. Run Docker build. This is the command to that. Run Docker build command, and next Docker push command. So this will push the new images to our Docker Hub registry. So once this is completed, deploy stage will be triggered. And in this deploy stage, we have written needs as build. Needs means this deploy stage will be triggered only when previous branch, that is build and push, will be succeeded. So in this branch, again, GitHub Actions will spin up a server, and in that server, firstly, what we are doing is configuring our server, that is GitHub server, GitHub Actions. That server GitHub Actions will be created with our AWS account. And how do we connect our account with the server? Using secret key and secret access key, right? So that is what we are doing here. So we are configuring our server with our our AWS account. And next, as the we have already spent our Kubernetes EKS cluster in our we have that EKS cluster running in our AWS account. And then once we run this command inside our server, that cluster will start reflecting in that server. So that cluster will have be now having the server configurations. Sorry, our server will be having the cluster configurations. And next we are installing Helm in that server, and simply we are deploying. How we are deploying? See this command, Helm upgrade hyphen hyphen install, means if application is not running, it will install that. If it is already running, it will upgrade that. Upgrade means it will upgrade those images of front end and back end. So this is the release name that I was talking about. Whatever you will give here, that will be reflected in your here templates backend.config dot release dot name. This dot release dot name will be replaced with this one, dot rating app. And where our charts files are present inside this folder, that is the rating app, that is inside this folder. And hyphen hyphen create namespace. If namespace is not created, it will create a namespace called project 4. And yeah, this is the same. And hyphen set, it will run these commands simply. Needs dot build dot output dot tag, which means it is referring these tags that we have updated previously. And it will simply deploy a a new version of our application inside our Kubernetes cluster. If you don't get it, bear with me for some seconds. I will show you how to run this YAML file and it will get completely clear for you. And next, we have our rollback.yaml. So in this rollback.yaml, workflow dispatch means it is triggered manually. Workflow dispatch means, and input we are giving to that our workflow is which version you want to roll back to. By default, we are taking it as one, but it will ask for our value, some value, and that version we will be rolling back. And same here, all the same we have env tags in job. It will spin up. It will firstly configure the our AWS account to the server and simply update that EKS cluster, install Helm, and then simply roll back. And the command to roll back is here it is. Here it is. Helm rollback hyphen app name is here, that is rating app, and github.event.revision. Inputs.revision means which revision we want to roll back, that we will give here input, that to that revision it will roll back. And here we are verifying whether it has perfectly rolled back or not. All these logs will be shown in our GitHub Actions config files, sorry, log files. I will show you that. So now explanation has been done. Now let's start our demo part, or let's start building this. So now what I will do is I will copy all those workflow files inside this server. So for that ls-a. So inside this dot github cd dot github cd workflows. So I have copied those both file here. That is deploy.ml and rollback.ml. And now simply see git status. So there are some changes. Now we will add these changes and push these changes to our server. Sorry, our repository. Which repository? This repository. This repository, which is create a CI/CD. And once we will push it here, a pipeline will be triggered because we are pushing something to our main branch. So now let's start that. But before pushing, what we need to do is in our previous project we had something called what is that? We were using something called AWS EBS as an our external volumes. So we need to apply that manually. So for that, what we will do is we'll go to our previous project, that is project 3. Inside this KTS, that storage classes, take this file and come here and simply create a file called vim.cs. So now simply paste that here and get out from here. And now apply this first scaml kubectl apply -f sc.yaml. So storage classes have been applied. So now move to your project 4. Here git status. So there are some changes. Now let's add this git tag git commit -f. Just give any description. Git push main. So when you will start pushing your repository, it will ask you authentication first. So for that, what you will do is give your username. So it will ask for password. So now for password, we need to create a token. So come to your repository, come to settings. So here developer setting, password access and tokens, token classic. So I had this CI/CD already created. So let me delete this and create once again. So generate a new token, classic. So give any name, CI/CD Kubernetes, and give him access like repo access and workflow access, and then generate a token. So token is generated now. Take this token and paste it over here. Simply hit enter. So now it will push your code to that repository. Now come here and then so see our KTS CI/CD has all those files, GitHub workflow and also these files. And now our pipeline is triggered, but it has failed. Let us see why it has failed. Oh, we have not added the credentials, right? So let's first add those credentials. Come to setting, then actions, not actions, but secrets and variables and action. So here, let's create those. Give name, Docker username, and give the username of your Docker. Similarly, create for Docker password, and here give your password of your Docker hub. Password means you need to create a token. So I've copied my Docker password here. So now next is what we need is a secret key and secret access key of our AWS account. So for that, let's create a AWS secret access key, and we need to add that secret key. So now we have added all our secrets. That is AWS secret access key, Docker password, and username. And now let's what we'll do is let's make some another push to our server. So but we need to make any changes out here. So let's make changes in Redmi file. So here images, make any changes, and status test one. Give any command and commit push origin main. So to again ask your password because we have not set that what we say because we have not set that credentials globally. So we need to again give those credentials here. So password again. I think I will remove that password. I have it here. So the changes have applied now. Now let's see here. Come to our repository again. So now you will see this yellow mark, which means the pipeline is triggered. Now let's look into it. Again, we are getting some error. Let's debug this. We are getting some error in Docker login. Docker up token, Docker up username. Uh, we have given the same name. Let's check that. Docker up password, Docker up username, Docker up not password, but it is Docker up token. So we need to update this. So this is the error. So edit, not this, but this. So okay, let it keep. Let's keep the Docker up password only. Let's make changes over here only. But again, it will fail. Let's make changes here only. Docker up password. Right? Let's delete this. Create new and give Docker hub token. Docker hub token and password for that is here it is. We'll copy it. We'll paste it. We'll create. Now created. Hope this works now. Let's make again some changes. Vim again make some changes. Git status git dot git commit -1 test2 git main. So yeah, those are applied once again. Now let's refresh this. So pipeline is triggered once again. Now hope this gets again failed. So we were getting that error because here we are passing Docker username. We need to update it as a Docker hub username. So we are just passing a Docker. We need to change it because we have here see Docker hub username, and here I am passing it as a Docker. So we are getting that error. So we need to update that. So simply delete this. Docker hub username. So now tokens have been added. Um, hope this works now. So come back to your server, sorry, GitHub repo, and pipeline is triggered. And yes, now it has succeeded. See, log into Docker Hub has been succeeded. So now it is now building Docker Hub images. And once it will build, it will push those images to our Docker Hub registry. So yes, it has built those. You got again error. Not error we are getting. Unauthorized token has insufficient scope. What token we have given? I think public read, public repo read only. Oh, we have done wrong here. So the Docker hub we have created, sorry, Docker hub token we have created. That token has only repo read permissions. So what we'll do is we'll create a new token. Mm, this thing CICD expiration 30 days and read write and delete no delete read and write and generate. So take this, come back here. So there are a lot of mistakes, slight mistakes, small mistakes. Mm, actions Docker up token. I will update it simply. Update secret. So secret is now updated. Hope this works now. Let's make some changes again. Vim readme So refresh it once again. So pipeline is triggered. So now let's hope it will pass all checks. Yeah, it is building images. It has pushed the images, and you will see the post checkout code now. It will take some 45 to 50 seconds. Yes, build and push the Docker image has been succeeded. Now deploying to EKS Helm. So now it will start the next job. That is this. Code configuration has been done. Now configured email installed Helm, and we got error. What error we are getting again? Helm and Helm deploy. What error we are facing? Release does not exist. Huh? Release rating app does not exist. Installing it now. Okay, it is installing. And then error rating app template mongo stateful set yaml. Executing a template at values.mongo.replicas nil pointer. Okay, we made a mistake here. We never updated our values file. So let's see that whether it is right or wrong. Cat values.yaml. Yeah, we never updated our values file, right? So we updated that in our local, but in our server we don't have that. So let's what we do is mm, so let's take those files from here. So here it is. So I have copied that values file here, and git status git add dot git test 4 5 test 1 git. So now push has been done. Again, a new workflow triggered. Build Docker images. So yes, Helm is installed. Helm is now deploying. Now it will take time to deploy. But on the same time, you can come to your server and check that whether it has started applying or not. kubectl till get ns. See, our namespace project 4 has been created 25 seconds ago. kubectl get all in the namespace project 4. See, it has started creating all files and applying also. And one thing I have added in this YAML file is job. What job is here? This job will run automatically whenever MongoDB pod is applied. So yes, now it has successfully applied all the YAML files and manifesto in our Kubernetes cluster. Now it's time to access the application. Now I've explained how to access that application in our previous video. So we need to install that ingress first, right? So again, come to your previous files in project 3 in setup MD. Here I've explained how to access that. Here we need not to initialize here MongoDB replica set because I have already created a job for that, and this will be automatically triggered. So need not to apply this manually now. So but we need to install nginx ingress controller. Copy this command, come to your server, simply hit enter. So it will install all the required packages, and then kubectl get spc. So you will get this external API IP address. Now simply copy this, and then ns lookup. Again, if you have the actual real domain, you can map this external IP to that your actual running domain. If you don't have, this is the way to create a custom domain. So I'm creating that custom domain here. Simply hit enter. So it will take some time to reflect that IP address. So let's wait for that. By the time you can see all your YAML files, all your resources have been created. Like let's see kubectl get pv. See, we have two PVs created that too dynamically using security storage classes. Kubectl get pvc in the namespace project 4. See, both PVC is created and they are in bound with the pods. And if you don't know how to create this, how to apply those things, I've already made a video on that, like our project 2 and project 3. Watch our previous video, it will get completely clear. I explained how to apply those manually and automatically also. So we got a IP address here. Let's take this IP and then open your slash etc slash host. If you are user Windows user, come to your notepad. But you need to open your notepad in administrative mode. So let's open that first. Run as administrator. So come to files, open, come to this location, Windows System 32 driver etc. And here all files, hosts, open. And here simply update this that IP that you copied earlier with your custom domain name, whatever you name you want to give, myapp.local. And then save this and come to your browser, myapp.local. You should be able to access your application right here. And this is how you deploy it. And now you as many as pushes made to your this repository, that is create a CI/CD on main branch. This workflow will be triggered and a new image will be running on your workflow, as now I we have here. Now let me show you how rollback will be happening with the zero downtime, as I explained. Now what we will do is we will make some changes to our application that is in this file, login file. We will simply change some color over here, and we will push that changes to our GitHub repository. A new pipeline will be triggered, and that new changes will be applied to our application. You will see with zero downtime, applications will be simply up and running, and new changes will be simply applied to our application. So for that, come to your server. But before that, let me show you something. Helm Helm history in the so this will show you all the releases that have been made. So we have only one deployment made, successful deployment. You can see that here in actions tab. So we have only one successful deployment. That is what it is showing here also. One revision, that is revision 1, and it is successfully installed complete. And we will now make some changes to our application and apply those changes, and a new release will be pushed here. So let's do that. CD inside our what changes we will do. Let me show you first that. So what we'll do is inside our front end src pages in login page, we'll make some changes over here only, like dev. So this is running in my local. So I want to show you what changes we will make. So we will make these changes. So we will make some, now our application is looking something like this, and now we'll make it like look like this. That is, we will change this color. And for that, come here, cd project 4 rating app, inside of front end, inside src, side pages, vim login page dot jsx. Inside this, now we are making simple a ui change. Now uh, where is that change? Yeah. So we will change see a bg, it is white currently. Now we will change it to some other color. What color is that? Let's simply take this. And then I have made those changes. Now git status, yes, and git new git push origin main. And now we have pushed the new changes to our repository. Now let's see that in our repository over here. See, a new pipeline is triggered with new releases commit. And now you will simply see those changes over here. Wait for it to get completely installed. So build and push has done. Now it is deploying EKS. If you will come here and see those changes, how it is applying. kubectl get all in the namespace. Shift 4. See, you can see a new backend image has been applied in 6 seconds ago. Similarly, front end also 16 seconds ago, and it is still in container creating stage. See, it is running. See, a new changes have been applied here. And now let's see the release here. See, a new release has been applied here. So let me show you on a clear screen. See, a new version upgrade is completed, and the version name is 2. See, previously it was a complete new page, and now it has changed to its new colored. And now we will roll back. As I told, I will show you two workflows. One is deploy.ml and another is a rollback.ml. Now let's see the rollback.ml. It will roll back to our previous version, that is release 1, and you will see again the zero downtime over here. So now what we'll do is come here, and this you need to apply manually. In Actions tab, release Helm, run workflow, and give the name as one. As I told, by default it is one, and you can change anything. And on which branch you want to run it. So we have only main branch, so keep it main, and run workflow. And now this will trigger again. Helm release, rollback YAML. See, it has triggered rollback Helm. So roll back to related version, selected version. I think rollback has been done. Rollback was success. Happy helming. It is verifying whether it has successfully been updated or not. So rollout to finish. One old replica are pending to termination. So let's wait for that. And again, you will see that this color will go, and it will you will see the previous version, that is version V1, which had no color. It was completely plain white color. You will see that. So yes, now rollback is also completed. Now let's see whether they are up and running or not. So our pods are running. So simply refresh this. See, this is the use of Helm. You can simply roll back to your previous versions using zero downtime, and this is how uh, this is how you set up a complete CI/CD pipelines using Jenkins for Kubernetes. And yes, that's it for this video. We have looked into how to how to successfully convert our Kubernetes application into Helm configured application, and we have successfully deployed our application using GitHub Actions CI/CD pipeline, and ensuring that we get a zero downtime with high availability. We have also looked into how to roll back to our previous versions also. All the source code and documentation will be provided here in this repository that we have been maintaining from since last four projects. And yes, that's it. And if you guys are new to my channel, hope you like this video, and we'll make such more videos on Kubernetes. And please make sure to like and subscribe this video, and I'll meet you in some other video. And if you are done with deploying all your resources, make sure to delete your resources. And how to delete that, in project 3 in setup md, this is a command given. To delete your EKS cluster, simply take this command, come to a server here, and simply paste that here, and simply hit enter. It will completely delete your cluster. And once deleted, come to your AWS in instance. Now turn off this instance or terminate this instance as you want, and you will be done. Okay, thank you.